Hsin-Hung Cho from National I-lan University. The speech is entitled Charging Planning of Wireless Rechargeable Sensor Networks. Let's welcome.
Oh, thanks for introducing me. Good afternoon, everybody. I'm Hsin-Hung Cho. I'm serving as assistant professor at National I-lan University. It's a great pleasure for me to give this speech. And my speech title is Charging Planning of Wireless Rechargeable Sensor Networks. And in this speech, I will introduce some common topics about wireless sensor network. And second, I will introduce the wireless rechargeable sensor network. And finally, I will give a conclusion. And firstly, we need to know when IoT has not been proposed yet, this technology was called wireless sensor network. And this technology aims to detect some place which is difficult to arrival from human. For example, we know the diamond is rich in volcano. Some days we want to detect an unknown volcano, but it's impossible to ask a person to go there because it's so dangerous. So to overcome this restriction, the people can take the plane and strangle the sensors around outside or inside of volcano. Then we can obtain some information from sensors. But we meet this situation will meet first problem: how to obtain the geographic information from sensors. And this issue will take into account with coverage problem and connection problem. And in wireless sensor network field, when we want to construct geographic information or construct a geographic environment, the first thing we think is triangulation. Many kind of triangulation has been proposed, but the most widely used is the Delaunay triangulation. And this is because the Delaunay triangulation has an advantage that is all the vertex of triangles have some relationship of certain circles. So it means all the vertex will be covered. So the coverage is can be guaranteed. But there are some errors with the real environment. For example, this figure and this figure is a field of interest. Maybe it's a volcanic hill. Then we use the Delaunay triangulation for depicting the terrain. And we can obtain this figure. We can see that many triangles are composed to a whole surface. So, but we can see that there are some errors. I mean, the long-range triangulation defined terrain cannot be perfectly conform the real environment. So, to overcome this issue, we try to substitute the long-range triangulation with another function. We use the spline function. And spline function can make abstraction of the surface of object become smooth. We can see this figure. This is a submarine model. Then we can see the spline function curve can perfectly cover this model. So maybe spline function is a good choice for geographic construction. And there are three common spline functions. The first one is the Bezier curve, and second is B-spline function, and non-uniform rational B-spline function. The difference of them is by the degree. And the Bezier curve is a basic spline function. Spline function has two important features. First one is the curve is completely contained in the convex hull of its control point. And the control point can be graphically displayed and used to adjust to the curve directly. And this is the Bezier curve equation. And Pi is the control point for controlling the spline curve. And U is the vector in the curve. And Fi of U is a blending function, which also a piecewise polynomial function. And we can see this this figure. There are 5 control points. Then this curve can be smoothly. And however, we just mentioned the long-range triangulation can guarantee the coverage. But how spline function to ensure the coverage? For a spline curve of odd k, a point on the curve lies within the convex hull. We can see this figure. There are many control points. Then they will construct a convex hull, and the spline curve can be covered by them. So, and this situation can extend to a large scale. We can see the right side figure. So, and the main process between spline curve and spline surface are similar. The just mentioned is a one-dimension spline curve. Then we can add another direction v. Then we have 2 directions. So we can obtain a 2-dimension surface. Then we can use this surface to map to a real environment. And this figure shows the Delaunay triangulation defined terrain. And we just mentioned there are some errors. We can see there are many triangles to compose to a whole surface. And this figure is led using the sprite function defined, and we can get a smooth terrain. And the arrows are vectors of sprite function. So we can see the sprite function defined terrain can perfectly conform to the real environment. But now we just know the sprite function can provide a smooth model, but how can sprite function can ensure the sensors are able to detect all the targets in this field of interest? We just said convex hull is an important character for sprite function, and convex hull can be an indicator to determine this function whether cover the entire field of interest. In this figure is the Delaunay triangulation defined terrain, and we use the vertex of all Delaunay triangles to make the convex hull. And we can see there are the dark blue place, they are coverage hole. And the area is about 227. So in this figure shows the Delaunay triangulation cannot be fully coverage. And this figure, we can see the convex hull by sprite function defined terrain. The area is about 348 square meters. So it is larger than Delaunay triangulation defined terrain. The important thing is it does not meet any coverage hole. So it is full coverage. So it means the geographic information can be 100% obtained as long as we adopt a sprite function instead of Delaunay triangulation. And next, we will introduce the coverage and connection issue. And coverage and connection are the important considerations which ensure the basic functions of wireless sensor network. The solution of coverage and connection are most based on the energy efficiency. This is because sensors have limit battery energy. And we need to understand a thing. If we want to detect more field, we can use larger coverage radius. But the larger coverage radius can consume more power. So we see the purple coverage area cover the 2 target, but we also see there is many redundant coverage. So we try to short the coverage radius like this. And in this case, we have saved more power consumption. But the detecting distance between any 2 sensors are different. So this is a very complex problem. So if we have not defined coverage scheme well, then some coverage hole will happen like this. And return to the sprite function defined terrain. We can see the 2 pictures in the top side, and the right side is the 2-dimension diagram, and the left side is a 3-dimension diagram. They are the same case, and in this case, the coverage radius has not been reduced. So it is a full coverage, but we can see that there are very many overlap area. So it means it will consume very much power. So, and we try to design an optimized mechanism to reduce the redundant transmission range and achieve high power conservation. And we can see these 2 figures. And most of sensors have smaller coverage radius. Maybe the total coverage is also closer to the full coverage. In this way, we can save more power. In this problem, because it is an optimization problem, so if you want to solve it, you can use dynamic programming or some meta-heuristic. And next, we will introduce the connection problem. Connection problem is similar with coverage problem, but focus on whether data has been transmitted successfully. And sometimes, connection problems are often accompanied by mobility and delay theorem. And the underwater wireless sensor network has these 2 problems, delay theorem and mobility at the same time. And the design of WSN take uncertainty into account. The first one is underwater sensors are unable to communicate with each other since their timers do not have a synchronous connection. And the second is underwater sensors are affected by ocean currents, which have uncertain mobility. So sensors are unable to obtain correct location information of any sensors. all situations result in the entire WSN having a high delay. And we can call this situation as a delay-tolerant network. And firstly, we need to know the median of propagation of UWSN is not radio wave, but sonar. So it is more easier to hinder by the underwater environment. So the so-called delay-tolerant network is mean a sensor must to tolerate each object which has a high delay. So they unable to transmit in epoch. But it can wait some time until another sensors is ready for transmitting. And delay-tolerant network can be roughly divided into two types. First one is scheduled contact, and second is unscheduled contact. The scheduled contact is we add a base station to this situation. The base station must have priorly knowledge of the schedule of all sensors. For example, when the right sensors want to send a data to the left sensor, and the left sensor is leaving, then base station will tell the right sensor what time the right sensor will come back. So the left sensor is come back, so the right sensors will in that time to send the data to the left sensor. So it means the base station is a centralized management for the schedule arrangement. And another type is unscheduled contact. This kind of delay-tolerant network routing can subdivide into opportunity contact and predict contact. And the difference is whether the scheme uses the relay or sync. Sometimes base stations are not suitable for certain scenarios, such as bio monitoring or deep sea detection and submarine rescue. And it means the object has very high mobility. For example, in a case of dolphin detection, but the dolphin have a huge range activity, but it's possible to deploy the base station everywhere. It's too costly, so we change to adopt the relay or sync. And opportunity content is when a sensor wants to send a data to the another sensor, then the left sensor has leaving, and the right sensor will send this data to a relay. And this relay will wait for the left sensor, then forward this sensor, this data to it. So it's opportunity contact. And predict contact, it means this situation is all the uncertain factors. So we need to make a prediction scheme to predict the object what time it's come back, or what time it has enough ability for transmission. So this scheme most based on the history information. So if you want to solve this problem, you can use the popular deep learning to do that. And next, we will introduce the wireless rechargeable sensor network. And also, there are many research about energy efficiency have been proposed, but there is no one can guarantee each sensor has not run out the battery. So wireless rechargeable sensor network will use the wireless charging technology to enhance the efficiency and enrich the flexibility of WSN. And there are 4 common wireless charging technologies. The first one is magnetic induction. This charging technology commonly used in our mobile phones. So we know the charging distance is very short. And the second is magnetic resonance. And the concept of this kind of wireless charging technology is like the tuning fork. You can knock a fork, and another fork will resonance too. So if the vibration frequency of the device is same with the charger, then it will create some current. But also the distance of power transmission is longer, maybe 3 meters. But it is very hard to keep the same vibration frequency for a long time. So this kind of wireless charging technology is not suitable for our research. And the third is laser light. Laser light is this kind of charging technology has longest charging distance, but it has very high power, so it is dangerous for human. And the last one is microwave conservation. This kind of charging technology is combines safety and charging distance, so we prefer this method as the main charging technology for our research. And the microwave conservation can divide into directional antenna and omnidirectional antenna because directional antenna can provide strong power, so we choose this one as main charging technology. And the wireless rechargeable sensor network scenario can be simply divided into the indoor or and the outdoor scenario. No matter what kind of indoor or outdoor, we must to deploy the charger around the sensor, then charge the sensors. And wireless rechargeable sensor network can subdivide into fixed charging and mobile charging. And in an indoor scenario, maybe we can deploy the charger around the sensor. Then the sensor can be charged as long as the charging area has covered land. In this case, charger can be placed freely in anywhere in a factory, but it will meet some problems. Like this. If there are some obstacles in the factory, then some shielding effect will be happened. So this situation will be increased if the antenna is adopt the directional antenna. So most of research in this topic are used the omnidirectional antenna. So we will, in order to avoid the shielding effect, we try to place charger under the ceiling. Then the charging direction is from top to down. And due to the distance between ceiling to ground is so long, so we adopt directional antenna, but it's no problem because it can be work successfully if the charging planning is designed well. And maybe when the deployment way has been defined, the first problem will be encounter how to know where are the better position to deploy chargers. Maybe we can deploy more charger to fill the coverage hole, but the planning cost is more expensive, especially for a low density environment in a large scale area. So so we need to find out the better candidate position for charger placement. Since we know the sensor position and we can know the candidate position, so in order to find the candidate position for chargers, we can let the sensor to project to the ceiling with a cone. This cone represents the maximum charging area. Then we can find many circles on the ceiling. And these circles may have some overlap area like this. And the middle point in this overlap area is the candidate position. It is because the position, this position is composed from at least 2 sensors. So it means this position allows to charge at least 2 sensors or more. And we can obtain the middle point of overlap area by the sensor's position and the intersection of the project circles like the white point. Firstly, we know the coordinate of sensors, and we also know the radius of the projected circles. So we can further obtain the circle formula like these 2 equations. Then the intersection points can be obtained by the simultaneous formulas. So we can obtain the coordinates of intersection points, these 3 points. And when we got the coordinate of intersection point, we can simply get the middle point according to the number of the sensors. Like this, there are 3 sensors, so we put the 3 in there. So this figure shows all the projected circles. We can see the green lines. And the blue place are the obstacles, maybe the machine or anywhere. And we can find there are many circles. So there are also many overlap areas. So how to it's impossible to deploy the chargers in all the overlap area. So we need to find out a better charger placement, which is a very difficult problem. So we will try to define this problem and use the meta-heuristic to solve this problem. And our problem definition is by using linear programming, and we encode a solution that the length is based on the number of candidates. And each bit in this solution represents a real position. And the value is a Boolean value. So it means if this position will deploy a charger, the value will be set as 1. Otherwise, set it as 0. So the main goal is objective function is to minimize the lower cost. It means find a solution which has a less number of 1. It means there are few charges in this situation. And there are some restrictions. The first one is the power is received the I-sensor node from the I-charger need to larger than the power consumption of sensor I. And the distance from I-sensor to I-charger most less than or equal to the active charging distance. And amount of energy is generated from the J charger to the I sensor node most greater or equal to the I sensor node from the J charger. Then next we try to use simulated annealing to find the best solution. And firstly, well, we will randomly generate initial solution. And firstly, next we will randomly choose a bit, then change 1 to 0 or 0 to 1. Then we can obtain a new solution. Then if the new one is better, then we will adopt this new solution as the input solution for the next round. If it isn't, then we will use the SA's unique exponential function to conditionally accept the least poor solution. So then we may find a better solution by this meta heuristic. Also, we can try the taboo search. The process is similar with SA, but TS add a taboo list to avoid to record the best solution in recent times. But SA and TS are the single solution based meta heuristic, so their global search ability are not good. So we will try to use the population based or swarm intelligence based meta heuristic. And this is GA based charging planning. And there, GA has 3 key process like selection, crossover, and mutation. But since the time is limited, so we go to the results. And we also use try to use the n-colony optimization solution to solve this problem. And the result of fixed charging planning, we can see that SA and TS cannot provide best charger planning. This is because SA and TS belong to single solution based methods. So we can see that there are still many overlap areas, and some sensors have not been covered. And the result of the GA and SEO, so far GA is the best method, and we can see that it has a smaller overlap area. ACO is a good method, but in this case, ACO is due to a continuous problem, so which may be in a bottleneck. And we will quickly review this problem. And the outdoor scenario means we use the self vehicle to carry out a charger then walk around the sensors, then charge them. But this makes this problem definition and the concept of this problem is very similar between outdoor scenario and the indoor scenario. So we will only introduce the indoor scenario for mobile charging. In order to achieve freely charging, we set a platform under the ceiling, and there is a little gap for charging vehicle which can move in this platform freely. And the charging direction also the top to down. And the encode solution includes two information. First one is charging order and the charger state time. For example, there is a sensor will run out the battery soon. So the charger vehicle will firstly charge it and maybe stay more time so that this sensor can obtain more energy and extend his network lifetime. And this is our problem definition. Also use the linear programming. And actually, this problem is extension from TSP. TSP is a traveling salesman problem. So we did not discuss in detail. So, and we also try to some meta heuristic because all the methods are similar. So I only introduce SA. We can see that each bit no longer represents a Boolean value. So we change to use the charging order. So when we want to change a bit, it's not a good way. So we need to exchange 2 bits like this. And this is the result of mobile charging planning. And SA and TS maybe we can see that there is some large angle migration. So it's not good. It will waste more time cost for work for a long time. And we can see the GA for this problem. The efficiency is very poor. This is because we adopt the original GA. It means the solution structure will be broken due to the crossover process. And the best one is from ACO because ACO originally has the TSP operator like the checklist. Our checklist will avoid some repeat route. So, and this is the convergence curve. Please refer to it. And conclusion, before the function of wireless sensor network operate, the first things we need to get actual geographic information and maybe use the Delaunay triangulation, but maybe other function can be used to map this real terrain like the spline function. And the coverage and connection problem must based on the energy efficiency issue. And some network have the high delay. We call this situation as delay-tolerant network. And deploying the wireless charger can efficiently improve the network lifetime. And finally, whether it's coverage problem, combination problem, or charging planning problem, trying the meta-heuristics algorithm is a good choice. That's all. Thank you.
Let's thank Professor Zhou once again for his inspiring speech.